Hello. In this video, I want to look at an application. The research department for a hardware chain has determined that at one store, the marginal price of X boxes per week of a particular type of nails is P prime of X is equal to negative 4,000 divided by 2X plus 15 cubed. Find the demand equation if the weekly demand for this type of nails is 10 boxes when the price of a box of nails is $4. Okay, so the demand equation is this P of X function that we want to find here. So basically, we want to remind ourselves that to find the demand equation, that is P of X. But notice that means that we're going to have to find the integral of P prime of X dx. So what do we have? Well, we have the integral of negative 4,000 all over 2x plus 15 cubed dx. Now, notice in here that we have 2x plus 15 in parentheses all cubed there. So I'm going to take whatever's in that parentheses, in this case 2x plus 15, and I'm going to let that be u. And then I'm going to take the derivative of that. So it means that du is going to be 2 dx. Now, notice something. We have negative 4,000 here. That is not the 2. And we have the dx. So how do I get 2 to become negative 4,000? Well, off to the side or somewhere, 2 times some value, let that be y, is equal to that negative 4,000. In other words, I want to know 2 times what number gives me negative 4,000. Divide by 2, so y is equal to negative 2,000. So what I'm going to do is I'm going to multiply negative 2,000 on both sides of this equation, and that's going to give me negative 2,000 du is equal to negative 4,000 dx. And notice that this entire negative 4,000 is what we saw up here, and the dx here is still just that dx right there. Awesome. So let's replace stuff with what we have it as here. So this is going to become the integral of, instead of negative 4,000 dx, it becomes negative 2,000 du. And then all over, instead of 2x plus 15, that would be u cubed. And then bring the u cubed into the numerator. That's going to make that the integral of negative 2,000 u to the negative 3 power du. And then just take the integral. Just rewrite the constant here, which is negative 2,000. Sorry, the coefficient, not the constant. And then u to the negative 3 plus 1 is negative 2. And then out to the front, multiply that by negative 1/2, which is the reciprocal of that negative 2, plus some constant. Now, negative 1/2 times negative 2,000 is positive 1,000. U to the minus 2 plus c. And then just bring the u to the minus 2 into the denominator, making that 1,000 over u squared plus c. But don't forget to replace the u with what we said it was. In this case, 2x plus 15. So this is going to become 1,000 over the 2x plus 15 squared plus some constant. And this is the demand equation, kind of. This is a family of demand equations. Notice that this constant needs to be determined. How do we figure that out? Well, we go back to the question. In the question, it says, find the demand equation if the weekly demand is 10 boxes when the price is $4. In other words, that's telling me that x equals 10 when p equals 4. So replace everything with what it is. In other words, it's telling me that p of 10 is equal to 4. So go down here and figure out what p of 10 is. So p of 10 would be 1,000 over the 2 times 10 plus 15, all squared, plus some constant. Now p of 10, of course, is just 4, so we'll just replace that with 4. Then over here, that gives me 1,000 over 2 times 10 is 20, plus 15 is 35. And what is 35 squared? Well, that's 1225. And if you take your calculator out and figure out what is 1,000 divided by 1225, you'll get the following. You'll get 4 is equal to 40 over 49 plus c. And notice that we can just solve for c as a result. So do 4 minus 40 over 49. And you'll get 156 over 49. Good deal. Now that you have that, you actually know what the demand equation is. Just replace this c here with 156 over 49, and we have our answer. So that's going to give me that p of x is equal to 1,000 over 2x plus 15 squared plus the 156 over 49. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.